Hi, this is Mr. Moss, and we're taking a look at 5 different methods for multiplying multi-digit numbers by single-digit numbers. We use 5 different methods because each one presents it in a slightly different way to students, and we want them to be able to choose which of the strategies really makes the best sense for them. Because the way that may work for you and I may not make as much sense for a fourth grader. And so we offer them different choices. In the end, as long as they can find one method that really does make sense for them, we encourage them to use it. Having said that, some of the 5 methods that I'm going to show you are ones that we introduce pretty early on as ways to build that conceptual understanding, and they're not really a strategy that we want kids to stick with for long-term use, and I'll give you some examples of that. So let's get started here and take a look at method 1. Method 1 asks students to draw an array. So if I'm multiplying 18 times 6, I'm going to sit here and draw an array to show 6 rows of 18. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Well, this is going to take a while. So thanks to the wonders of technology and scrap paper, voila, here's our array. 18 times 6. So what we want to teach kids to do is to break that down. Because yeah, I certainly could count how many dots I have here in this entire array, showing me 18 columns, 6 rows. I could count all of these and just go one at a time, but we can make this go a little bit faster. I can sit here and I can count how far 10 is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm just going to divide those up right now. So we know that this part right here that I'm dividing up, that's 10 columns, each with 1, 2, 3, 4, 5, 6 rows. So that's a 10 by 6 portion. And that leaves for me, if I counted this correctly, I should have 8. 1, 2, 3, 4, 5, 6, 7, 8. Great. So right over here on this side, I've got 8 by 6. And the reason why that's helpful for a student is they're able to look and say, okay, I took 18 and I broke that up into expanded form, 10 plus 8. I decomposed that. Well, 10 times 6, we know we can multiply that pretty easily. 10 times 6 equals 60. And 6 times 8, they may have to refer to a multiplication chart if they don't have their facts yet. But 6 times 8, we know, equals 48. And so then all I have to do is to add those pieces together. I have 60 plus 48, add them up, and I get 108. So that's method number 1, and it's honestly not one we want kids to stick with because you can imagine drawing this out took me a little bit of time, and that's just for 18. Imagine if my problem instead was 78 times 6. Imagine me having to draw 78 columns of 6. It's not a practical solution. We offer this as a way of just building students' initial understanding of how multi-digit multiplication really works, and to show them that I can break things up in groups of 10 or groups of 20 and so forth. So another option is decomposing a larger factor. I'm going to use that. I'm going to use the exact same strategy, actually. The exact same problem. 18 times 6. So if I was decomposing this, I'm going to break it down using a number bond here. I'm going to show that that's the same as 10 and 8. All right, so I've got 10 and 8, and I know that for each of those, I need to multiply by 6. So I can do 10 times 6, and I can do 8 times 6. So 10 times 6 equals 60. 8 times 6 equals 48. And now I'm going to add those up and get 108 yet again. So you'll notice that really this is pretty similar to what I did in the first method. I decomposed it into 10 and 8. Here I've decomposed it into 10 and 8. I broke it down. I did 10 times, 10 and 8. Okay, sorry. I did 10 times 6 to get 60, and sure enough, 10 times 6 to get 60 here. 8 times 6 to get 48. 8 times 6 to get 48. So these are both the exact same strategy. I'm just showing it in a different way. In the first example, method 1, I drew it out using an array. Method 2, I didn't use an array as much or at all. I instead used a number bond to decompose 18 into 10 and 8. And I can show you the same strategy now using a larger set of numbers here. Let's do 234 times 3. Well, I can divide that up as well. I can decompose those to get 230 and 4. And each of those are going to have to be multiplied times 3. So I'm going to do 200 times 3. And we know how to do extended facts. My base fact is 2 times 3 equals 6. That's telling me my answer is 600. Now I have 30 times 3. 30 times 3 equals, well, 3 times 3 equals 9. So 30 times 3 is going to be 90. Look at how I'm keeping all of my place values lined up. Ones, tens, hundreds, ones, tens, hundreds. And lastly, I have 4 times 3. 4 times 3. I was keeping them lined up. 4 times 3 equals 12. And so right here, I'm going to add that up. 2, 0, 702 is my answer here. So once again, I'm able to decompose it. That's our term for when we break up a number. And by the way, decomposing doesn't have to be done into specifically place values here. Decomposing just means breaking up a number into smaller parts, but I'm breaking up into its expanded form, 230 and 4. And by multiplying each of those parts by 3, I'm able to get my answer, 702. So that's method 2. That's decomposing a large factor. Method 3, again, you're going to see this and you're going to say that it looks very, very similar, is using the order of operations. So let's again go back to one of the first ones that we started off with at 18 times 6 again. And I'm again going to decompose this just as I did before, 10 and 8. But this time, whereas before, I wrote down 2 different rows here, the 10 times 6 and then the 8 times 6. Here I'm going to write that as a single equation using my order of operations. I'm going to do 10 times 6. And I know that before I had to do 10 times 6, get my answer, 8 times 6, get my answer, and then I'm adding up those answers. So I'm going to say I'm going to do 10 times 6, and I'm going to add that to 8 times 6. Now, strictly speaking, with order of operations, I could solve that right now and get the right answer, but golly, I just love to put in the parentheses here. A student said to me, why do you need to put in parentheses? And they're true. They're right. You don't need to, because multiplication would always be done first. I just feel like adding in parentheses keeps it a little bit more organized. So to solve this, I'm going to go through really the same process that you've now seen me do a couple of times for this one. 10 times 6 equals 60, and 8 times 6 equals 48. 60 plus 48 equals 108. So again, this is really similar to what I just did. I just wrote it in a different way. Instead of having 2 rows here of problems that I added together, here I did it as a single equation. I was able to get my products and then add them together to get the sum. I could do the same thing with the second problem that we did. It was 234 times 3. So again, I'm going to decompose it just as I did before. 200 plus 30 plus 4 times 3. So in this case, it'll be 200 times 3 plus 30 times 3 plus 4 times 3. And like I said before, I don't need to put in these parentheses, but it helps me to be more organized when I can add in these parentheses to keep my work together. It just has it make more sense to me, I guess. Keeps it more organized. So in this instance, 200 times 3 equals 600. 30 times 3 equals 90. And 4 times 3 equals 12. So now I have to add those up. And like we did before, you can always rewrite those and do stacked column addition. Here I can do 600 plus 90 plus 12, because I know adding these going across might be tough for some students here. 2, 0, regrouping, 702. Right there. So again, this method, very similar to the others, using the order of operations. The difference is just how you're writing it and how it keeps it organized for students. Method number 4, we're in our home stretch here, is using partial products. And for this one, I'm going to go straight to that last problem. I'm not going to do 18 times 6 anymore. You guys get the idea with this. For this one, I'm going to do 234 times 3. But for this problem, when we do partial products, we want to write it in the vertical method. 234 times 3. When I call it vertical method, it sounds like some crazy new way of doing it. It just means we're not writing it across, but we're stacking it. This method, I'm just going to tell you ahead of time, is one that we really want students to understand and be familiar with. They don't necessarily have to pick it if they're solving a problem themselves, but this really is an important one for them to have a clear understanding of how it works. So I'm just going to emphasize that for you guys right now. So for 234 times 6, what I'm going to do is I'm going to look at the place value of each of the numbers in my top factor, what the value of each of those is worth. So for example, to get us started here, I know that my 2, I always work left to right. So my 2 here, it's not just 2 times 3, that 2 is worth 200. So I'm going to write that out over here. 200 times 3 equals, I know my answer is 600. And now I'm moving on to the next place value. I did 200 times 3, so I'll put a little check mark there. Now I'm on to 30 times 3. That's not 3 times 3, it's 30 times 3. So 30 times 3, all right, I've got 90. That's all set. And now lastly, 4 times 3, that really is just plain old 4. It's in the ones place. 4 times 3. 4 times 3 equals 12. So I've got 600 plus 90 plus 12. I'm going to add those up to, oops, going a little too fast. 9 plus 1 is 10. We're regrouping. 702. You may be thinking, gee whiz, I mean, this is the same strategy that we did right here. 600 plus 90 plus 12. We added it up. Got 702. Method 2. 600 plus 90 plus 12 added up to get 702. Well, of course, these are all going to give you the same answers. It wouldn't be a very good multiplication method if each one gave you a different answer. The idea is that we arrive at them differently. And the reason why we like partial products, first of all, is because it's going to be really helpful to help kids keep their work organized when they're doing 2-digit by 2-digit. Here we've got 3-digit by 1. Once we start adding in a second digit for our second factor, it's going to be very helpful for keeping kids' work organized, but also it really shows them how they arrive at the answer, that 600 is the product of 200 and 3. 90 is the product of 30 and 3. 12 is the product of 4 times 3. Put it all together, just as you put those expanded form pieces together, you put these partial products together, and you get the total product of 702. The last method is the one that we've all been waiting for, the standard algorithm. This is the way we all learned it when we were young. 234 times 3. All right, this is the way we all did it growing up here. 4 times 3 equals 12. I'm going to put down that 2, and I'm going to regroup the 1. And, this is why we don't emphasize this as much for students. We expose them to it, but we don't really encourage it as much because, for example, 4 times 2 equals 12. I put down the 2 and I regroup the 1. Well, why do you regroup that 1? We all know that you're supposed to. We all know that that 1 goes up there. But why? It doesn't teach that place value understanding, that understanding of the number sense of why we're splitting up the 12, putting the 2 right down here, regrouping the 1. It doesn't explain that. 3 times 3 equals 9, plus that 1. Now that I've added it, I'm crossing it out. 3 times 3 equals 9, plus 1 equals 10. So I'm going to put down that 0, and I'm again going to regroup that 1 now. 3 times 2 equals 6, plus 1 equals 7. So this will get you the right answer. There's nothing wrong with it. And honestly, a lot of students transition to this method because it's faster after they've developed a strong understanding of why a method like partial products gets them to the right answer. So this leaves you with 5 different methods for multiplying multi-digit numbers, 2 digits, 3 digits, 4 digits, times single digit factors. We have the standard algorithm, method 5, the last one we've introduced. Method 4, partial products, definitely something we encourage students to be comfortable with, and we're going to do a lot of practice with it. Method number 3, using the order of operations, using your parentheses to keep your pieces organized as you go to multiply them. Method number 2, decomposing a factor and writing a large factor and then writing smaller multiplication problems to address each of those parts. And originally, method number 1, drawing an array. Good when you're working with kind of smaller multi-digit factors. You don't want to use it with bigger ones. This has been Mr. Moss looking at multiplying multi-digit numbers by single-digit numbers, and I hope this was a helpful guide for you. Have a great day.